Now that you are familiar with complex numbers and how to manipulate I and what I means, it's time to now start talking about what do you do with expressions that contain I. How do you add, subtract, multiply, and divide them? And we'll first go over adding and subtracting. When you're adding and subtracting any expressions with complex numbers or imaginary numbers, you need to pretend just for a moment the I is just like any other variable, like an X. We know that it's not a variable, it's a constant, but we're going to pretend like it is. So in the first example, 3 plus 5i plus 2 minus 3i, we're just going to go ahead and add all the like terms, making sure we account for any negatives and parentheses. And since everything is positive, I can rewrite this as 3 plus 5i plus 2 minus 3i. There's nothing to distribute or anything like that. So our like terms are the 3 and the 2, and then also our positive 5 and our negative 3 for the i's, giving us an answer of 3 plus 2 is 5, and 5 plus negative 3 is 2i. It's as simple and straightforward as that. The only thing that changes when you're trying to subtract complex numbers is the minus sign has to be applied to everything in the parentheses. It's kind of like distributing a negative 1. So you need to make sure that you use this negative on the 4 and on the negative 3. You use this negative on the 5 and the positive 2. And when you do this, we can start to rewrite it as negative 4, because a negative and a positive is negative, positive 3i, because a negative and negative is a positive, negative 5, and negative 2i. Let's go through and look for our like terms. We have 4, and we have negative 5, and then we also have positive 3i and negative 2i. Go ahead and start to combine these, and you get negative 4 and negative 5 make negative 9. Positive 3 and negative 2 make positive 1i, so we just put I. And there's our simplified expression. So let's take a look at an example where a lot more is happening. Number one mistake that people do when they see this is they think that they're going to have to distribute the 4. They think that we're going to do 4 times 3 and 4 times 6. This is not true. There is a minus sign in between them. So instead, you need to first distribute that negative to the 3 and to the 6. Since we have a positive here, there's nothing to distribute. So now I get 4 minus is still there. A negative and a positive 3 make a negative 3. A negative and a positive 6 make a negative 6. And then we just have plus negative 1 minus 2i. Now right here it says plus and negative. If you wish, you can just write down minus. That's fine too. Alright, let's go through and find all our like terms. We have 4, negative 3, and negative 1. And then we also have negative 6i and negative 2i. So let's combine those like terms. 4 minus 3 is 1. 1 minus 1 is 0. So I have 0 left over for the real. Negative 6 and negative 2 make negative 8i. And we can go ahead and simplify this just as a negative 8i. We don't need the 0. There you go. Now let's talk about multiplying. In multiplying, we multiply the constants and we multiply the i's. So we're going to multiply 5 times 2, 5 times 2, and we're also going to multiply I times I. and that's going to give us negative 10, and I times I is I squared. Now we learned in the last set of notes that I to the second power is equal to the square root of negative 1 squared. So let's plug in the square root of negative 1 squared. And that's going to give us, it's going to basically cross out that square root sign in the exponent, and that's going to end up with a negative 10 times a negative 1, which is positive 10. Okay. In other words, whenever you see I squared, you're going to replace it with a negative, we're going to replace it with a negative 1. Moving on to the next one. This one looks a lot like we would if we needed the FOIL, and that's exactly what we're going to do. You can choose to distribute the 2 now or distribute it later. I think I'm going to go ahead and distribute it now. So let's do 2 times 4 first, and then 2 times negative 3 second. That gives us 8 minus 6i, and all this is still in parentheses, times 7 plus I. Now we're going to make sure we do all the sets of FOIL. So at this point, this is when we do FOIL. So we're going to do 8 times 7 and 8 times I. That's going to give us 56 and plus 8i. Then we're going to do negative 6 times 7 and negative 6 times I, which will give us negative 42 minus 6i squared for I times I. So I'm looking through here, and I'm noticing that I have a few things to do. First off, I have 56 and 42 to take care of. So 56 minus 42 is 14. Now we have plus 8i minus 6i squared. And I squared, now we know, is negative 1. So negative 6 and negative 1 makes positive 6, and positive 6 plus 14 makes 20. So 20 plus I squared. Oh, sorry, 20 plus 8i, not I squared. Now, when we are multiplying, sometimes it happens that we end up with kind of like the exact same thing, same numbers, just one's positive with the plus and one has a negative with the minus. When this happens, they are called conjugates. Conjugates is an important idea. It's an idea that's going to pop up throughout the year. So basically it's just one has plus and one has minus. That's what conjugates are. But it's very interesting what happens when you multiply conjugates. Let's take a look at this. Let's go ahead and try to FOIL this problem out. 2 times 2 is 4, and 2 times negative 5 is negative 10i. 5i times 2 is positive 10i, and 5i times negative 5i is negative 25i squared. We now know that we can go ahead and plug in a negative 1 into that 25i squared. So there's a negative 1 for the I squared. And negative 10i and positive 10i is 0. So these cancel out, and I'll bring down the 4. Now notice now I need to make sure I simplify the last bit of this. So that's going to be 4 plus 25, which is 29. So, something to notice right now. When you multiply conjugates, notice what we started with. We started with two complex numbers, meaning that they had i's, right there. But we ended up with a real number. So what happens when you multiply conjugates? The answer is a real number. Okay? In other words, it eliminates your i's. Okay? It eliminates your i's. So if ever you need to get rid of your i's, you multiply by conjugate and the i's will go away. So when we are dividing complex numbers like 2 and 3 plus 2i, that's the key, is the conjugate. We don't want i's in the bottom. So we're going to multiply the top and the bottom by the conjugate. The conjugate of 3 plus 2i is 3 minus 2i. Make sure you treat this as parentheses though. What you do to the bottom, you also do to the top. On the top we have distribution to do. That's 2 times 3 is 6. 2 times negative 2 is negative 4i. And on the bottom I have 3 times 3, which is 9. 3 times negative 2, which is negative 6i. 2 times 3, which is positive 6i. And lastly, 2 times negative 2 will give me my negative 4i squared. We have a negative and a positive 6i, so those eliminate. 6 minus 4i stays on top. And now I have a 9 minus a 4 times a negative 1 for the I squared. Negative 4 and negative 1 make positive 4, and 9 plus 4 is 13. And I know this actually doesn't look like it's much simpler than what we started with, but it actually is simplified. We don't want an I on the bottom. Let's take a look at this one. This one is actually a little bit easier. There's just an I on the bottom, so we actually do not need to multiply by a conjugate for the I on the bottom. Instead, the way to get the I go away is to turn it into an I squared and replace it with a negative 1. So multiplying it by just an I, top to bottom, will make it go away. So now I have 1 minus, 1 times I is I, negative 2 I times I is negative 2I squared. And on the bottom is going to be 4 times I squared. We have some negative 1s to plug into these two things. I minus 2 times negative 1 over 4 times negative 1. Negative 2 times negative 1 is positive 2. And now we have negative 4 on the bottom. The numerator is not in standard form, so let's put the 2 first, the I second, and rewrite the denominator. And this is the simplified term without the i's on the bottom. Okay, if you have any questions, let me know, leave in a comment, and I'll see you in class.